Hello everyone, my name is Newton Rodrigues. I would like to thank the opportunity to participate in the event and the teachers Evaldo Santana, Paulo Fernandes, Jonas Barros and Raimundo Freire in the preparation of this work of the title Impact Points of Problem rocked by Telemetry and Slant Range. I will make the presentation follow the sequence: introduction, methodology, results, conclusions, and references. The rocket launch centers are of fundamental importance in space activity regarding scientific research and technological development, with responsibility like to vehicle assembly, rocket launch, trajectory monitoring, and payload radial, which is a set of measuring equipment or satellite transport by a space vehicle to accomplish a given mission. The motivation for these works arises from the need to provide an alternative for flight safe to the rocket attitude, because only radar estimates the position of the rockets, and the need for continuous location of the points in essential condition for flight safe. And calling the telemetry antenna determines the direction of the target with azimuth, and the elevation angle information does not determine the location of impact point rocket. Object. Therefore, the object of this work is to present a new function for the telemetry antenna modeling telemetry antenna angle e slant range equipment, providing a function to determine the location of the final impact point. Methodology. In this figure, it is possible to understand applied methodology, where the antenna receives the onboard signal, performs the tracking, and extracts the PCM signal, and compare with the reference PCM signal for estimate the distance of the rocket. The telemetry antenna informs the rocket direction with azimuth and elevation. Two, we make the composition of the polar components, resulting in the estimation of the impact points, where it shows how the distance signal in relation of the rocket is obtained through the phase compare of the PCM signal. With the information of the azimuth, elevation, and distance from the target, we carried out the reference change for the position of the rockets. Results. With the information about the target azimuth, elevation, and distance, we perform the reference change to the rocket position and individually compare the X, Y, and Z coordinates. Results coordinates on the x-axis. The curves are constant until the final moment of the tracking. shows that this coordinate is valid. Result coordinate on the y-axis. In these components obtained by Telemetry-Slant, the range is less susceptible to noise compared to radial. Shows that each component is valid. Also, results coordinate on the z-axis. The performance in the results present by slant range proves that this coordinate can be used to obtain the impact point of the rockets, as well as demonstrating a great stability of performance. Results composition of x, y, z coordinates confirm the evidence that the fusion of the data from the telemetry antenna and the slant range equipo can be an alternative to obtain the final impact point and still be used in the tracking the triangle. In the indication of the impact point indicated by the location at point radar and the unit of the telemetry and slant range system present a distance error of only 232.64 meters. The results obtained from the coordinates used with the fusion of the data from the telemetry antenna and from the slant range equipo, it did not undergo any addiction filter treatment whenever they were bare in terms of noise compared to radial. In the table shows the standard derivation of the difference between the coordinates between the position of the sensors on a time of great stability of the reading. Conclusions. In this work has delivered a rocket position obtained method in real time using data of the telemetry antenna and slant range device. This method can be used as an auxiliary research in the tiger monitoring and the indication of the final impact point, increasing the safe lives for this type of vehicle, and reduction the search field for rescue and reduction in the FDR of the final impact point obtained by radar. I would like to thank the Alcântara Launch Center, the State University of Maranhão, and graduate program in computer engineering, and the Fundação for supporting research in science and technology development of Maranhão. Some reference used. Thank you.